All right, good evening. Hopefully everyone is well. Let me get everything straightened out here. My desk. I have this huge desk, probably 3 feet by at least 2 feet, or 4 feet maybe. 4 by 2, it's probably pretty close to that. And it still feels like I don't have enough room. I need another 2 feet on the end of it. But that's the way it goes. If you have the space, you fill it up. That's just kind of the laws of nature. It's like Murphy's Law. All right, so we're going to move on and start talking about the system software. And we're first going to start talking about operating systems, but we'll get there in a second. Let me get my OneNote open here. I don't have that yet. And I get a new one. Put that in my lectures. And call it, I don't know, lecture 25, I think. And down here, DOT. Okay, well, it's on the bottom, but that's okay. Let's move it to the bottom. That was bad. Control-Alt-Delete. Or not delete, sorry. Control-Z. And that's your best friend in the whole wide world, right? My best friend, anyways. I love that command. What's going on here? There we go. Just give us plenty of room. All right. Hopefully I don't have to worry about it later. Okay. Oh, this was a tricky one. The problem is there isn't really... Well, we'll get to it. I'm going to do a lot of talking and less note-taking today. But we'll see how it goes. I'll try to put some things up there, and we'll maybe bounce around to some different things. All right, so first, let me talk a little bit about system software. It's interesting. There's several different kinds of system software, but so system software are things that can run directly on the CPU, and doesn't really matter what the rest of the things are going on the computer. This isn't completely true. The definitions are really loose, so that's why it's difficult. So there's 3 main things, though, that we're going to look for, and that's operating systems, and that's the base program that gets used to boot up the computer, and then you can interact with the computer using it. And we'll talk about that for a bit. And then there are compilers. Now, some compilers are operating system specific, some are not. Some can work without an operating system actually even on the computer. And then also there's something called middleware. And so let me talk just a minute then about what isn't operating systems. So any kind of an application that you have to start. So Microsoft Word, a browser, a mixer, the software I use to stream with, those are all applications. And so, and on a phone it's really easy to figure it out, right? So on a computer it's not as easy because sometimes some things come with the operating system, but they're not part of it. So application, right, is anything that can run. So Spotify would be another one. That's a perfect example. It's an application, right? You have to go and download it. And I think there's a free version. It's far and away better than any, I think. Well, maybe there are better ones out there. So this is the best one I've ever tried as far as just the streaming service for it. I do like it a tremendous amount. Don't use it as much as I probably should, but in any case, there's then the operating system runs things on the base level. Now, also there's a thing called middleware, and that's the third type of thing that could go into this system software. And middleware are things that exist between an application that you open and but above the operating systems. So I'm trying to think of a good example of middleware. What they are is their services. So, actually, I do know, right? So, the microphone that I'm using, it's a Elgato Wave 3. That microphone has a mixer to it. And is it an application? Well, yeah, kind of, but it's also a mixer specifically for this microphone. So you could maybe call it middleware, maybe technically it's not, but it's certainly something that helps me use this microphone better. If I knew how to use it, that's a different story, right? So there's that, but then the other thing, so that would be kind of an example of middleware, although I'm not exactly sure that it would have to be embedded. So maybe we're talking drivers or something like that. Yeah, I think that would be the case. As we're going to be talking drivers, really, in order to figure out what middleware, where middleware is. Because it's not something that you necessarily boot up, but it is useful in interacting with peripherals, which would be input and output devices. So there's that. Take that for what it's worth. Not that much, honestly, because these things are, like I said, they're very loosely organized. Now, when we talk about operating systems, it's not loosely organized. So I'll talk about what you need for them. And for many of you, if you go on to take upper division classes at another school, you're going to get a chance, hopefully, to take an operating systems class. And in that class, you're going to learn a whole lot more about operating systems. So in this case, we're going to overview today and next time, which would be Monday, and I'm just going to go over kind of a real broad sense, just a working knowledge of kind of what an operating system is and how it works. And then if you ever, that way you'll have that content knowledge if you need it. And it's an interesting thing, because in some ways, actually, this lecture is more important than many of the others, because you will be using operating systems in the future. And in fact, they've become quite important, potentially. Okay, so those are two other things. The system software, leave the rest behind. It's not a big deal, but there are things that can run independently. Well, middleware doesn't run independently. Okay. All right, so let's do the typing thing here. Let's type. Go here, go home, go to 36. Operating systems. Operating. Okay. And we'll do, I'm going to do this one. Okay. So the operating system it's going to control everything. Well, it's not everything, but it's close to it. Or it delegates that control to somebody else, to something else. So first thing I have is it needs to control computers, hardware. I should make that possessive, huh? And this shouldn't be possessive. Yeah, failing at English. It's a good thing I'm in computer science, right? Not in English. I would say the same for all of you. Well, I mean, English is a good enough subject, I suppose. I happen to like computer science. I happen to actually think computer science is the best discipline in all of the disciplines at a university. And if I had to put one second, I would say, well, math is up there, but history is probably number two. And that's my personal preference, so you don't have to agree with me on that one. But we hopefully will all agree on computer science. We're not going to be forming tribes and getting our pitchforks out and attacking the math department or anything. Let's not do that. But some of it's kind of just fun little banter. And I'm sure that the math department thinks that they're the most important, and the physics department thinks they're the most important. This is great for them. I'm happy for them. And I happen to agree for those people that it would be true for them. Okay, so these are things that kind of necessary things for an operating system to work. And so one of the other things it needs, or it's kind of tasks, makes it easier to use the system. And we'll talk about that a little bit, and you'll see kind of how that's improved over the years. But you think about it, right? When you're using the computer, do you even care what the RAM is doing? Maybe. But for the most part, you don't even know what it's doing. Do you care? Not really. And so, right, there's a lot of these hidden things that the operating system just takes care of, and it's fine. Now, if I'm in my VDI or VM, and I can't use my microphone, that's an operating system's problem, potentially, and I have to figure out why that is. So, in fact, it's a problem I've run into recently, because that same mixer that I talked about is running in the background on my computer all of the time, and it just boots up automatically when I boot, and it boots up in the background. I don't even see it or know that it's there necessarily. The problem is it grabs control of the microphone. So the microphone is allocated to that mixer. When my VDI wants to use the microphone, it can't, because it's assigned to the mixer. The interesting thing is most input-output devices, your mouse, your keyboard, your speakers, all of those don't have the same that same requirement. They can be used by multiple different processes at the same time. It doesn't hurt anything. But for microphones, they're required to be program specific, and so that can be kind of a headache. The good news is, right, I can just use my headphones. Right, so that's fine. I even have a real nice hook on the wall. Not that I'm bragging, or I think the hook cost $3 or something. It took me longer to order it than it did to put it on the wall. So, that's a little piece of advice. If you ever found yourself where you're working from home, one of the most important things I've found is that you want to have redundant systems, so that if you have a problem with connectivity of one of them, like say my microphone went out, if my microphone went out right now and I was informed of that, then I would be able to easily switch to my headphones, switch the inputs, take me a minute or two. I'd be able to switch the inputs and keep going. So that's something that just would recommend. Not necessarily that you have to do it. The other nice thing is, right, because I have those headphones, I have them, they're wireless, but I usually leave them plugged in because I don't use them very often. That way they're fully charged all the time. So, yeah, all these different things. Okay. So here are two examples. I've got a couple of really good examples, I think. Why is that not letting me go over? So one of them is drag and drop. Why won't that let me go over? There. Oh, that's weird. The controls went out, but it worked. Okay. So drag and drop file management. So if we think about this, right, let's say I have let me get something that's not crazy, right? So I've got this file that I use for our stuff. Well, now you know all the things I know, right? And so, but if I wanted to take a new file, and I could just drop it in here into these folders, and it would make the copy over, or either a copy or a move. It depends on context, right? Because if it's from a drive, an external drive, it'll copy. What is this? Oh, that's our syllabus, I think. So, yeah, then there's a syllabus. There's the schedule. I don't even know what that is. I haven't opened it up and look. Oh, this is... These are the... I should go through these and actually talk about them. Flynn's design. So, yeah. That'll be good, because I was just thinking about kind of the rest of the semester and how it's all going to work out. Because I'm looking at some of the chapter, like chapter 11, I'm going, I don't know that most of this applies too much. I mean, it's interesting material, but it's not necessarily something we need to do. Because it's just more advanced topics that... So maybe we won't. Maybe I'll just come back to that document I just opened. So it's a good thing I actually opened it. Yeah, performance analysis and performance measurements and analysis. Yeah, that's nice. I mean, this is great stuff, but I don't know that it's pertinent to this. Anyways, drag and drop, right? So it used to be before you actually had to type it into the software. I'll explain how that worked in a minute as well. The other one is plug and play. The other big one. So plug and play means there we go. See, now that worked. Okay. So plug and play means that my mouse, okay, comes in a combo with my keyboard. They're both wireless, has a single dongle. I just plug that dongle in and it all works. That's plug and play. It's an example of plug and play. So it knows how to deal with things. So that's and that's managed by the operating system. And that makes it easier, right? Because I don't have to go, in fact, in the old days, if I bought a new graphics card, I would have to go find the drivers for that before I could even boot it up. Or I'd have to put a disk drive in and get the drivers and stuff. And so, yeah, I could connect it, but I didn't know how to use it until after I put the drivers on the hard drive or let the operating system know about them. So, and that would be the same for a microphone or a headphones, a webcam, any of that kind of thing. Those used to be that you had to specially go out and get the software to do them, to run them. That's not the case anymore. We now have a plug and play, which means that it'll bring in a basic version of these things, and then if you want to get an updated version of them, you'll probably go and get that. Now, for some things, right, like for a mouse, you don't have to worry about it. It's going to be fine. There's not really a lot to it technically. But maybe a webcam you might. Certainly a graphics driver or a motherboard, you want to make sure you're updating those drivers. Okay. It must have control of the processors. I say processor or processors. Most modern computers now have multiple processors, but if there's only one, then, well, I guess your cell phone would only have one. I think. Most cell phones, I think, just have one. Be interesting to look that up, but, and actually, I should tab over. And all other resources. So the operating system is going to be the thing that's going to manage your microphone, your mouse, your keyboard, to figure out what is going on, right? When you type a key on the keyboard, how do we interpret that? And the operating system is the place that interprets that, decides which application that goes to, right? So if I'm typing here, that's one thing, or I don't necessarily want to look at that. Right? Or if I have Teams open, I'm sending a message to one of my teammates, then that would be different too. Those are two different applications. Microsoft Teams. All right, so okay, so there's really three things that it must do, though. So let me actually just create a new box here. OS primary tasks. That's probably the best way to say it here. So the first thing we have to do is process management. So in process management, what we're talking about, and we'll come back to all three of these, and I'll go into them in a little bit more depth, but I want to just say what the primary tasks are here first. So it decides who gets processor time. So which program or thing that's going on in the computer, things that have to be executed on the CPU, who gets to go when. And we'll talk about different strategies to do that, and how that can actually have an effect on the end user, at least a little bit, and what makes them particularly attractive or not. So, but it needs to, so it's deciding what goes into the process and what doesn't. Not processor. What applications get access to the CPU and when. System resource management. I should capitalize those, huh? So, yeah, okay. So, system resource management says that, right, if there's that RAM, it's deciding who gets which RAM, or if you get the RAM, or how that works. It decides things like virtual memory or any of those kinds of decisions. Those are all resource management decisions. So those would be important, right? So like, say if you have some speakers on your computer, what gets to send information to those speakers and what doesn't. And so those are things that the operating system would have to take care of. And then the last one, oops, I could probably just call this security. And there's a reason why I say errant here instead of malicious. So protecting resources from errant processes. Because if an application gets corrupted and things are going wrong with it and it's not working the way it's supposed to, then the operating system can intervene. And that's where you'll see, like, the browser's not responding, or the program is no longer responding. I get that several times, especially, this is interesting too, especially when I'm in something that I'm doing full screen. Let's say I'm playing a game full screen, and I Alt-Tab back to a browser. So it changes the resolution, because most games that play in full full screen, they're going to have a certain resolution. You play it at that resolution. Sometimes you can change it, sometimes you can't. If you can't change it, most of the time I've had problems on my main computer when I'm switching between the two, and it depends on which thing I'm doing. But I can get programs to fail to re-engage again and it has to. I think it has to do with that change in resolution, but I could be wrong on that. But the computer will actually notice those things and actually stop those programs from continuing, or at least give you the option, hopefully. So, but it also does include things that are on the computer that are not nice. However, most operating systems by themselves won't do much. Right? If you get a virus on your computer, it isn't really nothing the operating system can do. All right. So let me just talk about some history, kind of how operating systems came to be and how they work. Back in the olden days, even before I was using computers, I know this is a long time ago, right? Back in the 60s and 70s, or even into the 50s, we go back that far, there wasn't a screen, so there was no monitors. And actually, one of the things we could put up in here and that makes easier to use is a graphical user interface, or GUI. Let me put that in there. I think that's a good one to put in GUI. I'm going to define that as graphical user interface. So it's a way for, interface means a way for you to interact. So in this case, right, it's the mouse moving around on the screen, and it'd be the mouse moving around on the screen. In fact, I can double click, I can interact, I can click elsewhere on the screen, and depending on where I click, it will change the behavior of the application. So it's just, that's important. So just keep that in mind. Okay, so right, the original computers are very, very old computers. What they did, they didn't have a monitor. So what happened is it would just simply print out what it was doing. And so it printed it out on these old printers, and they're called dot matrix printers. It doesn't really matter, but that's just kind of interesting because all the letters are made up of dots. It's kind of a cool little way to do things. We don't do that anymore with laser or inkjet now. But they had on the sides of the paper, right, they had those little, I don't know if you may have seen them, but they had these little tear-offs that had holes in them so that when the printer would spin forward, it would move the paper. And so now we have different things, right? We have little wheels and stuff that actually can grab the paper and move it through. But at that time, they didn't. They had these wheels that it would engage in these dots. Dot matrix printer paper. Actually, this is a great example. Let's pull this out and show it here. So this is a great example here. So in this case, it shows one that's, and it tells you what it is. And the original ones were this color. And it's hard to get a scale and know. It does give you good dimensions. This is bigger than a normal piece of paper. But notice here on these edges here, there's a little dashed line there. And that means that's perforated, right? So it's easy to tear off. And then these pages were all connected. So they would lay, one would lay up, and then the next one would be face down, and then face up, and then face down, and then face up. So that way it was in one big spiral. Not spiral, one big serpentine, I guess is the best way to say it. Oh, geez, I just got rid of the 5% off for paper I don't need. There you go. Okay, so, and for input, they didn't have keyboards. What? How do they input any information? Well, I've talked about this. I think I talked about it, right? We had these punch cards, And these punch card decks. Now I don't remember ever using them, but I talked to my mother who worked at the University of Minnesota in the late 60s, and she did some data entry, and they were actually would punch out the holes on the cards for things, and then they would feed them into the reader. So that was interesting, but that was at a time when there were other ways to read in information. It was just happened to be that was part of the reason, the way they did it. So what happened is originally the punch cards were good enough because they were ran about the same speed as the computers. But we already know, right, the computers get faster. Well, the punch cards can only be read so quickly because it's a physical medium, right? It's a card. It kind of looks like a half sheet of paper with a bunch of holes in it. And so they needed something to go faster because the computer would just be sitting there wasting time waiting for the punch cards to come through. Because you would put a program on the punch cards and it would run from the punch cards itself. It's actually quite interesting. And if there was count all of your blessings, because you live in a world that is absolutely wonderful when it comes to computer science. Some of this I didn't have either. I'll explain that in a minute. But it used to be, when they programmed something on these old cards, they would hand it in, and then they would get their results back 24 hours later, which meant if there was a syntax error or a logic error in their program, it wouldn't work. And so now they have to go back to the drawing board. And at a lot of schools, they limited how many times you could turn in a process. So you were much more careful about making sure that the process was working or would work before you would submit that to see if it would run. So, and again, any output that delivered would be printed out on a printer. So, but for input, they had the punch cards. So what they did, actually, it's ingenious. This is ingenious. They knew that if they used electronic or magnetic tape, rather the big ones or smaller ones, that could be read much faster on the computer, right? Because the head could spin quicker, and it's just not that physical. The same physical card, right, that could get stuck together or whatever, and that'd be a problem. So what they would do is they would have smaller computers that, again, don't have hard drives, but only thing their purpose is to read from the card and put it on electronic tape. So then they would do that, so then it was just a matter of switching tapes. And you could put multiple programs on the same tape, whatever it was. So it was pretty interesting when it comes to that. That's kind of the real old base stuff. Then they got monitors, and then we got keyboards, and then it just kind of and then a mouse. I think I mentioned it before. So I think last time I talked about Hidden Figures, and Hidden Figures, if you watch for it and look for it, you'll notice that how the input and the output work on the computer. So if you ever do watch that, or if you decide to watch it again because you've watched it in the past, pay attention to try to see what, does it use keyboards? Does it have monitors? Is it only using the printer? How does it do that? So take a look at it, because I think you can actually get that out of that movie. It's pretty accurate when it comes to that. It's pretty neat, actually. All right, so one of the other things, so I think I mentioned at one point that in the late 90s I worked at a wire harness plant. And they had old computers. They used old computers with old dot matrix printers to test their software. Is they had all these programs that were written to do this. It was actually quite ingenious. You'd plug in, you had a special adapter that was attached to the computer, and you'd plug this into a physical box that had wire connections in it with clips where you would put all of your connections, and then you would press the button and it would simultaneously go through and make sure that all of the electrical connections were in place properly. And if they weren't, maybe there was a pin that wasn't seated, or a solder wasn't done right, or whatever, right? And so, and that's what I did when I first started there, is run those tests, hook things up, test. It's really boring work. I didn't mind it too much, but it was pretty boring. One of the ways I made it more fun. Work is never fun. It's always work, right? But one of the ways I made it more satisfying is what I would do is try to beat my time. So I would time myself for 5 minutes. How many could I do in 5 minutes? I'd try to beat my time. It just made the night go faster. Because I was doing that overnights when I first started, then I switched to days. Anyways, you guys don't need to know about my whole history. It's mostly boring. That's kind of exciting, I guess. It was my life, though. So it was my life. It was boring. Where I was going with that. Okay, so they had several testing computers on the connected. All of those computers were connected to the mainframe. And they had an old mainframe, probably from 1980 or maybe even before that. And they were still using it in the late 90s. And what that mainframe had is it had all the programs on it. And so I could interact with that and get those things down from the program. So the computer I used did not have any RAM on it. Or not RAM, I'm sorry. It had RAM and a processor. But it did not... it didn't have a hard drive or any storage on it. If I would have unplugged it from the mainframe and tried to boot it up, it wouldn't have worked. So that's really interesting. It wouldn't have even booted up. So it needed to be connected to that network. Now, it's a much more limited network than the internet nowadays, but that was that. And so that was what I wanted to talk about a little bit. Is that was kind of the wave of computers. And if you've ever heard the quote about, I can't imagine, I think it was by IBM. One of the lead people at IBM said, I can't imagine the United States ever needing more than, I think it was 100 computers. May have been 1,000. It was some really low number. Couldn't imagine the United States needing more than 1,000 computers, let's say. I think it might have been 100. And boy, was he wrong, right? He missed on that one a little bit. But the computers he was talking about were mainframes, and they serviced many, many, many people in an organization. But as the price came down on them, it became easier and easier for other organizations to buy them, including places like the Anoka-Ramsey Community College. All right, let me just talk a little bit about. Actually, there's another movie, and I really highly recommend this. I think I might have mentioned it before. It's called The Pirates of the Silicon Valley. It was a made-for-TV movie, so you could watch it with your parents. It's perfectly fine. Or your younger brothers and sisters. And I think it's pretty riveting. It talks about how Apple kind of came to be. It also kind of... It shows the parallel tracks between Apple and Microsoft, because there was a time where both of them were the newcomers. And now, 30 years later, more than 30 years? Yeah, because most of the events in that take place in the 80s, in the early 80s. In the late 70s, early 80s. So I guess, what is that? 40 years. 40 or more years ago. These companies started hitting the scene and started becoming important. And when that happened, there was a transition between the mainframe people that made the mainframes, the IBMs and the DECs, And when we switched over into Microsoft, and I talked about that a little bit on how that all worked, but let's talk about the operating system a little bit. I'm going to talk about Microsoft first. So, it's absolutely brilliant. And I mean, Bill Gates was a visionary in some ways because he saw that the operating system was the important thing when it comes to the computers, especially since IBM, remember, was open architecture. So other people could make IBM compatible parts. So then they would make all the parts, and then they could buy the operating system from Microsoft. So, and this is a scene in the movie that's absolutely brilliant, and this is true to life, is that Bill Gates and his team, they'd been developing some software for this computer called an Altair, which is super, super nerdy and cool, but not anything like what you guys think now. Input-output on that was lights and switches. Much more basic than what we've got now. So, but he was writing some software for that, and him and his team. But they met with IBM. They got a meeting with IBM to provide an operating system for them. And he said, yep, no problem, I can provide an operating system. They hadn't written an operating system. They didn't know anything about it. But one of the guys that was in the organization knew somebody who owned a operating system, who had created an operating system. And the operating system was called Quick and Dirty operating system. And so Microsoft went and bought that operating system from this guy for $15,000. Well, they renamed it DOS, or Disk Operating System. And they put MS for Microsoft at the beginning of it. So we can still actually get a look and feel for that still today, right? So if I go to... Okay, CMD. Oh, yeah, okay, this will work. So if I go to this command prompt like this, oh, now you know my username. Oh no. So this is what DOS looked like. CD ... dir. So, right, we've got some directories here. Public, my directory, this A, Osterwick-da, and then admin, and then, so this is how you actually worked with computers. Now, oh, it actually tells me how much free space I have. I have a lot. 285 gig free. That's pretty nice. So, this is how we did things, right? And so, well, let me go back to CD, go dir here. Oh, well, we can see all the different things. I've got music in OneDrive and OneDrive RBA and OpenVPN saved games. Games? I have games on here? Okay, well, there's a folder with nothing in it. Well, I guess. There you go. So, the administrator, the network administrator, did a good job of taking that stuff off. Okay, so, yeah, geez. On a work computer having a folder called saved games. I don't understand that. All right, so, in any case, so it's got, and you could move through them, and I probably could talk about more about how these work. It's important to get at least a little bit familiar with these command lines. I don't use it for my daily work, but some of my coworkers do. They will actually compile software here. They do different tasks in Microsoft DOS, which it used to be that DOS was the main operating system and Windows was an application. In fact, my first computer was that way. So in order for me to use Windows, I had to boot Windows up. It wasn't part of the operating system. And then when they came out with Windows 95, then that became the operating system. And then you had an emulator like this, command prompt. Well, actually, I think at that time they still had DOS running in the background. Eventually, they didn't anymore. I think that was XP. And that what happened is this emulator like this actually, or command prompt, is an application built into the operating system now. However, it does give you more control, and you'd have to. I mean, to show you an example, it'd be hard, but it allows you to put all kinds of different tags and options and things like that, and be able to do them and change them much more quickly. So, just wanted to talk about that. So let's history of Windows. My caps lock got on, so I was shouting at the thing here. Oh, wow. So the first thing I used was Windows 3.0. This gives you a look and feel, so that there was a 1.0, a 2.0, a 2.1. And you can see here, right, it's pretty chunky. Look how much free space they have. 303K. They only had 30 meg. And that tells you that was their total hard drive space. That's pretty small. Okay, so, and it got better with this, but still pretty clunky. And then we get into the Windows 95, Windows 98, and Windows ME. I remember all of them, right? 95 came out in 95, which is good. I think 98 did not come out in 98, though. Oh, it did come out in June of 98. Okay. And then ME, which is Millennial Edition, 2000. Only a couple years later. And that one, for the most part, wasn't. So there's an interesting history. I bought my first computer, DOS 4. I'm sorry, DOS 5 was the newest one, the newest DOS. And so I got DOS 5. That was the operating system I got on my very first computer in 1983. And then I got Windows as an application to put on it. Windows 3.1 or 3.2. Windows 3.2. Let's look here. Nope, it was 3.1. It couldn't have been 3.2. It wasn't released until after I bought my computer. So, yeah, okay. So, one of the interesting things. Oh, I brought it home, and within less than a month, DOS 6.0 came out. So it's like, oh, well, okay, well, whatever. Anyways, that was a good computer for me. Had it for a very long time, actually. So it was kind of, this is what would happen. DOS 3, very good. DOS 4, flop. I mean, literally, they released it in beta to a bunch of different companies, and then before it hit the market, they canceled it and just went to 5. And Windows 95 and 98 were both fairly successful because they were nice upgrades. ME wasn't widely accepted. People didn't buy it. And then they have NT, which again also wasn't really that it went on like servers and stuff, but it didn't go on a lot of people's desktops. And then XP was a huge leap forward in 2001. And notice here it's very close to some of these. I think NT stands for New Technology. So XP was very good. Vista, short-lived, not that long that people didn't really use it that much. Windows 7 was good. Windows 8 was good. Now we have 10. Now we have 11. Nope, nope. It's not. Oh, okay. So it's a free upgrade, so you can get it, and then they're gonna have a 365. So that's that. So let me bring this back over here. But if you'll notice, it's every few years, like 4 or 5 years, they come out with a new one. So the other one, computing one, is Mac OS. And if we look here, this is back to 2000. So before 2000, they had OS X. It was different. Or no, not OS X, sorry, here. They had some other development ones because it was back in the days of Apple. So I could look at the Apple OS, but it's all going to be similar. And so what they did is they started naming them after cats, different kinds of predators or cat. This one's the weird one. Kodiak is really a bear, but all the rest of these are cats: panther, tiger, leopard, snow leopard. Interestingly enough, every single one of these names up to here was, I believe, or at least up to this one, were all used by German tanks in World War II. They were all names for, they had a tiger, a panther, a jaguar, a puma, and a leopard. So then they get down here, and then they're like, okay, well, we're out now. We kind of ran out of different ones to put out there. So then they switched, and they switched to sites. I think most of them are like, they're, I think they're national parks or locations in California. Yep. El Capitan, Sierra, High Sierra, Mojave, right? That's a desert. Catalina. That's an island. Big Sur. Again, that's a mountain area. Monterey. That's a bay. And Ventura. So that one is, looks like that's the most current one. So the interesting thing about this is, if we look at the dates on these, they're way closer together. It's every year or two they come out with a new one. And a lot of times, Apple users or Macintosh users just automatically upgrade. So not the case for Windows users. Although it's kind of changing a little bit because they're giving it away for free. They had 2 different models. It's pretty cool, actually. So let me talk. There's one other main one in the field, and that is Linux and or Unix. And Unix is used a lot of times for database systems or web routers. So guaranteed that you're using Unix or some Unix code for this stream to get from my office to your wherever you are watching it. Okay, so there's that. Okay, I do want to get to some other things though. There's a couple other things I want to talk about. Back here. Okay. All right, so we're going to get into this and try to do it as quickly as I can here. These are things that in the process, so managing the process. So again, that's deciding who gets access to the CPU or any resources on. So the first thing is, in Process Manager, we have synchronization problems. So What that means is things need to happen at the same time on both ends. So that's kind of what synchronization means, so that everybody's doing it together at the same time. Yeah, so it's just important to make sure, right? Like if there's a bunch of CPUs, that they're all working on the same clock. And it can have different clocks for different things, but it needs to make sure that in each context that the clocks are being obeyed. That's basically what synchronization issues are. Because it would be a real bummer if the virtual memory decided that it needed to, go to the RAM and put some things into RAM when the things in RAM were still needed. We talked about that a little bit before, but we just need to be able to synchronize those things. Okay. So then long-term scheduling. And this is what processes get access to the processor. And that could be multiple processors, but in this case I'm just going to limit it to one here. And then short-term scheduling. And the difference is which process goes next. That's a good way to think about it. Okay, so one of the other things is there's several of the strategies for short-term scheduling that require us to pause a process. Context switching. So we're going to pause a process and we're going to switch to another one. So how do we save where we are? And so that's an important thing as well that process management needs to deal with. All right, so let's talk a little bit about, let me make a new box. Down here, back. I always wish there was an easier way to do this. All right, so types of scheduling. That's probably the best way to call it. All right, so the first come, first serve. So this is the same exact thing as FIFO, first in, first out. The only thing is we call it first come, first serve. So when a process asks to get access to the CPU, or when it gets started, it will get access to running the CPU. It will go into a queue or into a line, and it'll wait until its turn, and then when it comes up, then it goes in. Then it goes and it gets to execute. And then it doesn't give up until either it has a break, so it's waiting for, say, something to print or something to load from memory or something else, where it's just sitting there idle, not doing anything. Then it will, or the process terminates. Then it will pass control back to the operating system, so the operating system can grab the next thing. So one of the problems with this one is well, first off, the problem is it's not fair at all. Fair. If I have a process that's going to process once every second, and it only takes 10 instructions. It's going to run a little thing, do 10 instructions, and then it's going to turn off every second. So it needs frequent access to the CPU, but it doesn't need very long access. And timing is important. So, but what happens if another process is using this CPU at that time? I can't get access because I'm waiting in line. So that's a potential problem with this. So the next one is called shortest job first. And so what happens is that the CPU or the thing that gets access to the CPU, it's whichever one is the shortest in just pure numbers of lines of code or whatever, however we decide to do that. It's right. We define what shortest means, and then we say whichever is the shortest, and that goes first. This is really great unless we're really busy, in which case the longer programs or longer processes don't ever get access. That's potentially a problem. So the next one we have is round robin. So then we look at all of them, we put them all in a pool, and then we're going to give them access. We might put them in first come first serve, and then so it goes to the back of the line. But what happens is we're going to run it for a certain amount of time. We don't run it for the whole time. We just run it for a short time. And either it terminates, which is great, or it doesn't terminate. If it doesn't terminate, we're going to context switch. We're going to save our progress, and we're going to push it to the back of the line. By doing that, it allows this is the first one that kind of handles this process that needs access fairly often, but it doesn't access it very long, right? Because it's going to get its time slice, and that's really what we talk about here is time slices. It's going to get its time slice fairly quickly to when it needs it. It can be very timely. The next one is priority. So if there are things that are urgent, like that would, if we didn't do them right now, it would result in the CPU melting. Right? I don't know of any applications that are like that, but if we had one, that would be really important to run it. So, or the process that happens when your laptop is just barely it's out of memory and it's about to close, and so your operating system actually figures that out and will save everything for you. So that's really handy. So and then So things get higher priority based on how important they are. And then the highest priority thing gets access. We can build into that, that's actually kind of neat, a timer with the priority so that the longer it sits idle, the higher its priority goes up a little bit every time. So every time it doesn't get picked, its priority maybe increases just a teensy little bit. So then if it keeps not getting selected because its priority was low, eventually its priority gets high enough so that it will get in. So the next one is multitasking. Spell. So multitasking, right? That's what we're used to, right? I can have multiple programs open and they switches back and forth between them. It uses different processors. And actually, I want to talk about that for a little bit. Actually, let me put that down here and tab it in. And that's multi-threading. And then I did the exact same thing. Well, at least I'm consistent. That's good. So multi-threading is a little bit different. So let me just explain this on a real basic level, in that it takes your program and it breaks it into threads. And what that means is it's a chunk of the program that can be done at the same time as another chunk. For the most part, let's say if we're looking at Python, Python doesn't really support multi-threading except for one thing, and that's when you do a stream. And I don't know if you guys know how to do those or not. But if you're going to use streams in Python, then you definitely are doing some multi-threading there. And I know in Java there's ways to make something go multi-threaded. So at least my first thought is merge sort is probably the one of the most basic. If you know how to do merge sort, it's the most basic thing that I can kind of use to describe multi-threading or multitasking, multi-threading. So, yeah, multi-threading is just used for multiple different processes, and that way we can do them in parallel. That's basically the way to kind of think about it. So, right, yeah, merge sort basically says take the list of things, cut it into half, and then sort those two halves, and then merge them together when they're done. and then it does that recursively. So then it takes each half and it will cut each half in half. And so you can see that each one of those can be sorted on different threads or on different cores. And so we can kind of do it in parallel, and that speeds up the performance. We also do the same thing with quicksort. It's a different story. So then the next thing would be the resource management. There's a lot more in the book here that they talk about. I did not talk about a kernel. If you ever hear the word kernel, when it applies to operating systems, particularly it's usually Linux or Unix, the kernel is the core, the main part of the operating system. Did talk about, quick and dirty operating system, BIOS, right? That's the it's the very basics that are, basic input-output system. So it's the very basics to get the operating system so that it can connect to say your monitor or to your keyboard or to your mouse. And those are built into the motherboard. So that's programming that's in the motherboard. It's actually not part of the operating system. And this would be an example actually of, it's actually probably beneath the operating system, or at least beside. So it's not necessarily middleware. Yeah. Okay, so the resource management, I'm just going to talk about resource management instead of processor management, but resource management would be deciding who gets to print first, who gets to use virtual memory first, or where it goes, or how it works, or if two things are trying to write to the disk drive at the same time, which one goes and when, and how to schedule that. That's some of that resource management. Also, it would be things like, oh, hey, I'm going to assign the microphone to the mixer, and so that's important too. So that's resource management. There's some more to it, but most of it is just so high level. It's really hard to get into any of it. And then the last thing is security and protection. And we're not talking about virus protection. It's generally not included in operating systems. So you would need to, if you're going to do any of that, you would need to go out and purchase that. I generally haven't used it. I would say in the last 20 years, I probably used it for maybe 4. It tends to slow things down, and I don't really like that, so I don't use it. And the amount of viruses, if you're careful on the internet, you can just don't click on links that you don't know where they go and that kind of stuff. So you can kind of keep that down. All right. So we will next time talk about virtual machines, some programming tools that we use, including compilers and interpreters, and then we'll talk a little bit about Java, and that'll be what we talk about next time. Otherwise, I think I'm pretty much done. Yeah, that's all I've got. So that should give me some time to work on getting the rest of 5 graded today. So, all right, I don't see any questions, so I'm just going to let that go. And if you have any questions or thoughts or anything, I'm considering picking a day for Maria. I'd like to do some Marie stuff so that when I do start assigning projects that we have some more time to kind of work out how that stuff works. And so what I want to do is pick a day that people can actually come if they want it to be interactive. So I'd like to do that. Maybe it doesn't work out for you guys. I could switch to a Friday if we wanted to. If you have any thoughts on that, email me. So my thinking is that I'll switch so that after next Monday, I'm going to pick one day of the week and we'll just do Marie on that day. And then I'll switch back and do some more stuff and finish up the book. So, but, we're going to get 6 or 8 potentially, or a few of the Maria lectures. It'll just be about Maria and how to do it. So we'll set it up directly and I'll put it on my computer and kind of do a walkthrough of some of that kind of stuff. So if you have any thoughts on that, let me know. Or if you'd rather just wait till the end, but if we wait till the end, then we're probably looking at about 5 or so weeks, and there'll be 2 programming assignments, kind of back to back. And if you guys want that, that's fine too. I don't have an issue with that. So if we want to condense it, that's fine. Or we want to spread it out so we can have a little bit more time to work on things. That's fine as well. So if you have thoughts on it, let me know. I'm not going to put up a survey, I don't think. Just go ahead and send me an email. All right, I think that's it. I will talk to you